This
it will take
conference will
time.
now be recorded.
Normally, I may finish in 1 hour or it may take 1.5 hours. I'm not very much sure. Usually it will take 1 hour fully. If we want to extend for 15 minutes, we'll extend. Let's try. Okay. Rule resolution is the concept. It is an algorithm. In Pega PRPC, entire Pega rules process commander has been built based on rule resolution algorithm. Everything that you access on PRPC, this rule resolution algorithm will get executed. For every access that you do, rule resolution algorithm will run internally. Algorithm means it's a program. Okay, step-by-step program and all. See, if I want to access a rule, the rule will be picked and presented to the requester. You are called as requester. I have executed a flow. The flow is create insurance. When it is executed, as part of execution of my flow, I have requested for the flow. I have requested for flow action. I have requested for section. I have requested for expect to properties. All these are been requested, right? So all these rules are there present in my application, some classes, some rule sets. So that rules should be picked and processed and presented to the requester. This process of picking the rule, processing it and presenting to the requester is called rule resolution process. Everyone clear? But picking the right rule is rule resolution. Picking the right rule. What is meant by picking right rule? It is picking anyhow rule and it is presenting to you. Let me tell you one thing. See, I have a section by name customer details section. I have created this section in my implementation work class, division class, organization class, framework work class. How many places the same name section is there? 4 different classes it is there. When I am going to execute a flow, as part of my flow processing, customer details section is being used, requested. It has to be processed and presented to me, right? But out of these 4 sections, customer details section is there in work class, division class, organization class, framework work class. Which one out of these 4 has to be processed and presented to you as a requester? That has to be decided by the process commander. So out of these 4 will be presented or only one will be presented? Only one will be presented. Which one is that? Has to be decided by the process commander. For that, it will execute an algorithm called rule resolution algorithm. Rule resolution algorithm is picking the right rule and processing it and presenting to the requester. Right rule is the main point. Everyone clear? So now the rule resolution algorithm has 5 different sub algorithms. One is rule cache. Second one, class inheritance. Third one, rule set hierarchy. Fourth one, what is that? Rule set, class inheritance, rule set, rule availability. And fifth one, rule authorization. Sixth one, circumstance. These are all part of considerations in the rule resolution algorithm. These are all considerations in the rule resolution algorithm. When rule resolution algorithm gets executed, it is going to execute all these small programs. All together is, what is that? Rule resolution. All together is rule resolution algorithm. Everyone clear? So I'll talk about rule cache at the end. First, let's talk about class inheritance. Okay, listen to me carefully. You know inheritance and types of inheritances, right? How many types of inheritance we have? Pattern inheritance and 2 types, pattern inheritance and direct inheritance.
Direct.
I have my implementation work class. I'm talking about only work class. Even you can ignore about case type, no problem. Otherwise, case type also you can go, but you'll get confused. But anyhow, work class. In this work class, I created a section called customer details section. It is there in work class, division class, application class, organization class. All these 3 classes, same name, one section is there. It is also there in framework work class. It is also there in framework work class. I have a flow in my implementation work class. As part of the flow execution, customer details section is being requested. I have executed the flow. Now from which class the section will be picked and processed and presented to the requester. Always you remember current class. What is that? Current class of the transaction where you initiated. For the flow that you execute from implementation work class, the section that is going to be picked, is it from implementation work class or division or ordination or framework work class? Which one out of these four? Implementation work class, because that is the current class. Same example means the section is there in implementation work class, division class, ordination and framework work class. All the places same section is there. Now I am executing my flow from framework work class. In my framework work class, one flow is there, I executed. As part of this flow, customer data section is being requested. Now which one out of these four will be picked and processed? From the
framework work class.
framework work, because that is the current class. Always PRPC picks the rule from current. You understand what is the meaning of current class? If rule is not present in the current class, it has to take from the parent classes. There are two parents. This is the parent. Framework work class is also parent. Pattern parent, the rule is present. Direct parent also, the rule is present. From which parent process command is going to take? I am going to explain you. I'm not asking you. Look at here. See here, when you go to the class rule form, here you can see in the inheritance concept, there are two inheritances, pattern and direct. Find by name first pattern. What is the meaning of this? Whenever a search happens in the inheritance, always find a rule by pattern inheritance first. So pattern inheritance is taking first priority over direct inheritance. When this checkbox is selected, by default it is always selected. We will never change this even in enterprise. So which inheritance out of pattern and direct is priority? Pattern. How come? How come? In the class rule form, it was selected that find by name first. What is that? Pattern. Find by name first. Always you find by class name. In the inheritance, you look at the class name first, not the parent classes at the class rule form. Class name first, if you go through, which inheritance you are going to encounter? Pattern inheritance. So pattern inheritance is the first priority. So if a rule is present, not present in the current class, it has to take from the parent class. Pattern parent, direct parent, both classes it is there. From where it will take? Pattern. Suppose if I uncheck this checkbox, then it will take from direct. But we never do it. If you want to give the priority to direct inheritance, suppose, then you need to uncheck this checkbox, which we never do usually. Okay, so we have two inheritances, pattern, direct. Which is the priority inheritance? First priority, pattern. Second priority to direct. Which is the mandatory inheritance? Direct is mandatory, pattern is not mandatory, because LIC is a class, right? Is there any pattern parent for LIC? That is not mandatory to have. Okay, so direct inheritance is mandatory. This is with this inheritance concept is over now. Okay, so first point is in the rule resolution algorithm, when a rule is being requested by a requester, process command is going to take the rule from the class inheritance, considering the class inheritance. In the class inheritance, current class. If not present, pattern parent class. If not present in pattern parent, direct parent class. If not present in direct till it will go till the level of @ base class. If not present in @ base class, then rule not found exception. Everyone clear with class inheritance hierarchy? Online. Next one, rule set hierarchy. What is the next one? Rule set hierarchy. Listen to me carefully. So if you go to the application rule form, I'm going to explain you now this point. Application rule form. Here you see rule sets. What are the rule sets mentioned? Implementation, integration, ordination, integration. Go to parent application, framework application rule set, framework integration, ordination, integration. If you open a rule set, you see here validation mode. What is it? Application validation. Whenever this rule set is been encountered, it has to consider the application validation. I'll explain about rule set validation after some time. What is the meaning of application validation? Application validation is very simple. That is, if a rule is being requested by a requester, process commander has to look at the first rule set in the current application. What is that? Current application where execution has been initiated. In that application, first rule set not present, then second rule set not present, then third one not present, then so implementation rule set will verify not there, implementation integration not there, ordination. If not present in these four rule sets, then it will go to parent application rule set. This is the application validation mode. A rule will be try to find in the implementation application rule sets and parent application rule set. This is called as application validation. Parent application rule sets also not present. Parent of parent application rule set. Like this, it will go and verify all Pega rules process command rule sets as well. If rule is not there in any of the rule set, then rule not found exception. If rule is found anywhere in the hierarchy of rule sets, then it will take from one of the hierarchy in the order. First, it will look at current application, first rule set, second rule set, third rule set, fourth rule set, fifth rule set, sixth rule set, all this. Understand? And if not present in current application rule sets, where it will go? Parent application rule set. If not present in parent application, parent of parent, parent of parent, till what level it will go? Base class. The classes ka the rule sets. Which application? Pega platform application, Pega rules application related OOTP rule sets. Understand everyone clear? Online resources. All of you clear?
Yes.
Okay. Now, suppose what if I choose rule set validation mode? It was see, there was no application validation before Pega 7. Starting from Pega 7, application validation has been introduced. Rule set validation was there from the beginning, but today we are not using rule set validation. Mostly we are using always application validation. Application validation, you understand, right? Keep only that in mind. This one you can even ignore, but listen to me. If I choose rule set validation, before I choose, look at here. If I expand a version 1, you would see effective date, something like this. If I choose rule set validation, what else you see? Required rule sets means this is the current rule set, correct? For this, these are the parent rule sets. Like a class has parent classes, right? If rule is not found in the current class, it will look at the parent classes, correct? So if rule is not found in the current application first rule set, it will not go with second, third and all. It will go with prerequisite rule sets. These are called as prerequisite rule sets. That has to be mentioned. If I create rule set version 2, again I have to go to version 2, I have to mention this. Version 3, I have to mention. That will be highly difficult actually. So if rule is not found in this rule set, it will look at integration rule set and Cosmos. It will not look at organization rule set. It will not look at framework rule set because it is rule set validation mode. Rule set validation mode is the one where if a rule is not found in the current application first rule set, it will look at the parent rule sets called as prerequisite rule sets that are mentioned in the rule set only, not in the application rule form. Okay. So if you want all this, you have to mention everything there. But this validation mode is going to be deprecated going forward. So still it is for backward compatibility, and we will be always using application validation mode. Okay. So rule set hierarchy. Rule set hierarchy means this is the hierarchy. You go to operator profile, you see the rule set hierarchy. In the operator profile, I'm sorry. In the operator profile, you see rule set hierarchy. Leave about the rule set by name operator ID. I'll tell you other later. See here, LIC auto I order, LIC auto I int, LIC int, LIC INSUR, LIC INSUR int. These are framework related. In framework also you have organization rule sets, right? But why again organization rule sets are not mentioned here? Because already it verified as part of implementation. Again, no need to verify as part of framework. Okay, like this in the, and after all your application rule sets are completed, it will go to Cosmos or anything, UIKit, anything. And then it will go to Pega rules process command related rule sets in the same order that is mentioned in the operator profile. You watch this video once again. It's not easy to remember in it one day. Okay. So this is about rule set validation mode, and that the other one is application validation mode. Always application validation mode, you remember. So process commander is going to take the rule always from the current class, otherwise pattern parent, otherwise direct parent till base class, and always from the current application rule set, and so on by number in the application validation mode, parent application rule sets, parent application till Pega rules process commander rule sets. Make sense, everyone? Clear? Next, look at here. Next, these two are completed. You understand how the process command is going to pick from which class which rule set. And one more thing I'll tell you, rule set version. Rule set version is also important, right? I have a rule in the same rule set in 4 versions. From which version it will be? Latest version always, right? previous to previous to previous, like that also it will pick. In other cases I'll tell you. So next one is rule availability. This deals with versions. You already know that always a rule gets picked from highest version. Okay, now I'll give you one requirement. Requirement is that a rule set has 4 versions. The same is there in live server. Live server also 4 versions are there. Now the rule is there in 4 versions in current class. Now business has, okay, business is given you one requirement. Requirement is like this. This rule is also available in the parent class. This rule is also available in parent class. Okay, parent class also rule is available. Parent class rule functionality is different. Child class rule functionality is different. Okay, otherwise I'll tell you this way. Business has created one payment gateway section, UI form, in the framework application and its rule set, framework work class and rule sets. And the screen is being inherited by many implementations. Implementation work class 1, implementation work class 2, work class 3. They have a facility to modify it. They did a save as into implementation work class 1, work class 2, work class 3, all this, and they modified as per their need. And it is running. The business is running. It is in live server. Business has identified this issue and said that you should not modify like this. It is not allowed. Okay, it can be done in 2 ways. Anyhow, it has been done already. It's not that initially you identified it. After it is there in live, it has identified. Now business is asking these modifications should not be accessible. It should access from the parent class only. That rule should be picked. What you can do now? It is not possible to log into production server and delete the rules. It is not possible. So you need to make some changes such that the rule in the current class should not be picked, but parent class should be picked. This can be achieved by rule availability. One example I told like this, there are multiple. Okay, so this can be done by using rule availability concept. So I'm going to explain you rule availability concept now. Okay, this is one business scenario where you need availability feature. See, I'm going to explain you this rule availability concept with an example showing you by a property and section. For that, I need one rule set at least with multiple versions where versions have to be unlocked. Oh, already all versions are unlocked here. That is good. I don't have to spend much time here. Now I am going to create one rule that is called property to explain you availability. So anytime when you have a rule, I'll show you first existing rule. I'll show you any rule. You can open any rule. For every rule beside the rule label, you have one option available. Click on it. You'll see availability, available, not available, blocked, final. These are different availabilities. The requirement which we have discussed, this is the solution. This is the solution for this option is the solution. How I'll tell you. This availability also plays a key role in rule resolution algorithm. It is going to decide which rule to be picked. Based on availability, one of the factors is rule availability. Based on rule availability, also process commander will come to know which rule is the appropriate one to be picked. Class inheritance, rule set hierarchy, rule availability. There are 5 different options available in rule availability: available, not available, withdrawn, blocked, and final. We'll see all those 5 practically now. And I'm creating one property by name availability property. Some name I have given. So one, it is creating an implementation work class version 4. So I'm going to make this property as a radio button with a label, so that when we look at this particular radio button in the UI, based on the label itself, we should be able to understand from which rule set version it is getting picked and from which class it is getting picked. For that better sense, I'm doing it. This is from the implementation work class version 4. If you have a radio button displayed in UI with this label, you know that it is being picked from implementation work class version 4. For version 3, I will give a different label so that you don't need to go to live UI and find out at runtime. Only R3. Okay, and you just need to you just will come to know about by looking at the label, because intentionally I am giving different label for same property. I am going to create once again. Same property once again I am creating, but this time where I am creating version 3. Create and open. It will say prompt. Okay, and here you go now. Version 3. Will you be able to understand by this label itself? You should be able to easily say you need to make sure you check in it. Okay. Now the same property one, same rule again in another version. Version 2, create and open. What should I do now? For better understanding, I'll change the label to be version. If this radio button is displayed with this label, which means it is being picked from work class version 2. Same property once again I am going to create in division class. Whatever the version 4 I mean create and open. Parent class I am creating. So implementation, division class, version can be anything because I am not going to touch too much about this one. And same property once again I am going to create in the organization class. Everyone clear? Highest version, okay. And here you go. What is this? Organization class. So one property, same property is available in multiple versions of the rule set, multiple classes. Maybe even multiple rule sets also, okay. Okay, now I am going to create a section in the same class, that is the current class. I am going to create a section available section, create and open, highest version work class. And now I'll add this particular property, availability property here, convert to full section editor, submit, and here you go now, structural, what is that? Picker, radio button, and here you go now, I'll take that available property. So for all of the properties, the same property at all places I have created, all the properties availability is available. Now if I run this section, as part of this section execution, I am requesting for a property. What is the property name? Available property. Available property is there in 5 different instances. Which one out of these 5 to be picked? That has to be decided by the process commander, right? What is always class is the first priority. Out of rule set and class, which one is first priority? Class. So always current application, current class, first rule set, highest version, correct? This is the order. Run this. Which one has been picked? We can see it from the label itself. What has been picked? Work class version 4. From the work class, it has been picked of version 4. Version 4 is being picked from work class. So the highest version is the one which we need to focus while learning about availability. The highest version of a rule is its availability is available. When the rule availability of a rule is available in highest version, that will be picked and processed and presented from the current class. Understand everyone? It will not bother about previous versions, always highest version. Now I am making changes. Current class, highest version, I am going to make it not available. What did I make it? Let us see now. Not available if I make. Version 3 of same class version 3 is available. Same class version 2 is available. Parent class is also available. Current class, highest version is not available. Previous versions are available. Now I execute the section and see the output result. Based on the output result, you will be able to know about which version has been. I'm sorry, what about this? Did I check in that or not? Hold on. Actually, why it is showing work class? Somewhere I forgot one rule to check in, I think. Where is this coming from? Work and 03. I did not even give that, right? Is that property wrong property? There are 2 properties. Yes, wrong property. Sorry. Already find out this, sir. Okay. Anyhow, previous one will be working as it is, and this time you see implementation 4 version 4 of current class is not available. Version 3 is available, 2 is available, parent class also available. Out of all these, which one has been picked? Current class, previous version to highest. So if the highest version of a role is not available, then process commander picks what? Okay, process commander ignores that highest version not available, picks the role from the previous version. Picks the role from where? Previous version. Everyone clear? If the highest version of a role from the current class is not available, ignores only highest version. Previous version, it will pick. Suppose version 3 also not available, then version 2 also not available, then version 1 also not available, then pattern parent. So it will consider current class, previous versions it will consider, correct? This is not available. If the rule availability of a rule is not available for the highest version, that will be ignored. Previous version will be picked. For example, out of version 1, 2, 3, 4, 4 is available, but 3 is not available. Then which one will be picked? 4 will be picked. Highest version is the first point, correct? Now let me change this. Here you go. Let me change this to be highest version. Instead of not available, I'm making it withdrawn. What am I going to do? Withdrawn, and then check in. Highest version has been withdrawn. But what about the previous version of current class? Still available, right? Let me test it. Actions and then run. You see now what is happening. Which one is being picked based on the label? You should be telling me. Pattern parent rule is being picked. Highest version is withdrawn. Highest to previous in the same class is still available, right? But still,
Yes.
even though that is available, that has been ignored. Version 3 is available, version 2 is available, version 4 is withdrawn. When you withdraw highest version of a class, of a rule in the class, all versions of the current class will be ignored. That is the algorithm. The requirement I have told you, right? This is the solution for that requirement. It will ignore current class, all versions picked from the parent class. So if the rule availability of a rule is highest version is withdrawn, PRPC not only ignores highest version but also all versions of the current class and picks the rule from the parent class. So 3 availabilities we have discussed so far. One is allow processing. Okay, I'll take a Word document just for your better understanding. Allow processing and prevent processing. Prevent. So which of these 3 are going to come under allow processing? Availability, available. So not available, and what is the other one? Withdrawn. These 2 are going to prevent the processing of the respective version and current class all versions. Availability, available means highest version is available, that will be available for processing. PRPC will pick and process it. And highest version is not available, PRPC ignores only the highest version and picks the previous version from the current class and process it. If the rule availability of highest version of the current class is withdrawn, then all versions of the current class will be ignored and picks the rule from the parent class. Pattern parent also, all you withdraw that direct parent until it will go to base class. Okay, next I'll ask you some questions related to this. Hold on. And next, here you go. Highest version, I'm going to check out and make it final. What is that? Final. And then check in. Now highest version is availability final. All previous versions are available. Parent classes are also available. Actions and then run. Let us see what is being displayed. You tell me which one has been picked. Based on the label, as you know, you should be able to say.
Latest
What has been picked?
set version.
Highest
Is that the same final rule that has been picked? So final rule is also allow processing or prevent processing?
Allow process.
Final is also. See, if the highest version is either available or final, the same will be picked and processed. Then what is the difference? So what is the difference between not available and withdrawn? Not available ignores only that particular version, picks the previous versions of the current class. Withdrawn ignores all versions of the current class, picks the rule from the parent class. What is the difference between available and final? I am going to explain now. Both are going to allow the processing of the respective version, which is highest version, which is final. But look at here. This is the operator rule form, correct? I wanted to make changes to this particular form in the design. What should I do? Where should I start? Where should I start? That is the requirement is to modify this form. Where should I start?
Section
Live UI. I should start.
Yeah.
Live UI. Open the respective section. This is the section. I want to make changes. What should I do now? Save as. Where to save as? Into your application rule set. I'm trying to save as to make the changes. What is happening? It is not allowing me to save as. It says this instance conflicts with final record. You cannot do save as into another rule set. From one rule set to another rule set, you can save as You cannot save as if it is a final availability is final. That is the difference. So availability final means you cannot copy the rule from one rule set to another rule set. That is not possible. I created a payment gateway screen in framework application framework work rule set. My intention is in future, no one should copy this particular payment gateway screen into implementations to make changes. What should I do now? I need to create it as a final rule at the beginning, so that when they try to save as into implementation rule sets, it will throw error, it will prevent. Understand everyone clear? This is there in even in Java, any object-oriented programming, it is there. Final prevents overriding of a rule. You cannot override the rule into another rule sets, not versions, rule sets. Understand everyone clear? What is the difference between available and final? Available means it is available for processing. You can save as the rule from one rule set to another rule set for overriding. But final means it is available for processing, but it cannot be saved as from one rule set to another rule set for overriding purpose. Cannot. Understand? And blocked, it is very easy. Blocked means it won't be showing up in the rule resolution. I mean, like for a blocked rule, completely prevented. Highest version is blocked. None of the versions from same class or parent classes will be picked. None will be picked. Means everything will be ignored. Understand everyone clear? So 5 rule availabilities are there. Blocked will come under which category? Prevent processing, right? Okay. So rule availability, available, final, not available, withdrawn, block. So availability, available means rule will be available for processing. It can be copied from one rule set to another rule set for overriding purpose. Available final means it will be available for processing. It cannot be copied from one rule set to another rule set. Method overriding, like rule overriding, is prevented. And not available means rule will be ignored from the highest version, fixes the rule from the previous versions of the same class. Withdrawn means highest version is withdrawn, ignores all versions of the current class, fixed from the parent class. Blocked means finally it stops processing that particular rule. Everyone clear? These 5 will play a key role in processing the rule resolution. How many we have seen so far? Rule class inheritance, rule set hierarchy, rule availability. Everyone clear so far? Circumstance you already know, we discussed. We practically worked on it. Circumstance is also one of the criteria in the rule resolution algorithm. If a rule has a circumstance version, when PRPC encounters a rule, it is going to verify whether the rule has circumstance instance or not. If circumstance instance is there, it will verify the condition. Condition satisfied and date is qualified, then circumstance instance will be picked, else base version will be picked. That is pretty much straightforward. Okay. Next, rule authorization algorithm. Everyone clear so far? All these 4 you are clear? And rule authorization.
I have one question.
Block, it will block in all levels, right?
Block, that rule will not be processed. Simply, that rule will not be processed from any version, any class, any rule set. Current class, current rule set, highest version, current application, highest version rule set. If you block it, means you don't want that rule further to be available in the processing. Business has created one rule. They wanted to delete the rule. Is it possible to delete the rule from production? It is not possible. You block it, create a next version of the rule, block and move to live. That rule will never be picked going forward. Understand?
Yes, sir.
Yeah.
What is the question, other person?
So let's say we have a rule and we have circumstance that under a current class, like work class of implementation, and the same rule is circumstant under framework class as well, or even in the hierarchy back, like division class or organization class.
Okay.
So how it will be processing it, like?
Again, class inheritance is common. Condition, class inheritance, both will take priority, right? Current class, condition matching. Not matching means current class you have base rule, it will take the base rule. It will not go for parent class. Condition and all. Okay. So see, circumstancing doesn't deal with class inheritance actually. Circumstancing deals with same class, same rule set, same version, multiple instances. That is the meaning of actual meaning of circumstance. So see, if you are creating in parent classes, is there any meaning? Usually there is no meaning. If you are creating multiple versions, usually you don't need to. In one version, I want to create same rule 10 times. Generally, is it possible? It is not possible, but it is possible by circumstance with a condition. You never come across this type of situations in circumstance usually. Circumstancing you are doing means same version. Suppose that version is locked, then only you will go for next version of the rule set. In different classes, you don't create generally circumstances. Why do you need to create? Class itself is a specialization, correct or not? Class specialization is there, rule set specialization is there. Then what is circumstance specialization? See, if you are creating one version in division class circumstance, you copy that to work class and do again another circumstance, there is no meaning, frankly speaking. Why do you need to go for circumstancing? Already you created in division class, right? Copy to unit class and make changes. Correct? There is no need. This is again a specialization by class. You want in between rule set. One rule set rule is there. Why do you need to do circumstancing to copy into another rule set? Copy and make changes in another rule set. That won't impact anything here. That itself is specialization by rule set. Circumstancing is the specialization of creating the rule with condition in the same rule set, same class, same version. That is the main key point of circumstance. Got it now?
Yep.
Okay, now here you go. Customer details section I am trying to search. Customer details section is there in LIC class, Sun class, SBI class. How many classes is there? 3 different classes of 3 different applications. I logged into LIC application. I am able to open customer details section, able to access it. I have requested for customer details section. It is processed and presented to me because I have access to it. And now customer details section I am trying to request from the SBI class. Is it been processed? The processing has been prevented. Now process command is verifying my authorization, my authority to access the rule, whether I am authorized or not. An operator will be verified for the rule authorization process. Okay, see, you have operator ID. In the operator ID you have access group. Inside access group, what is being referred? Application, portals, rule, access roles. Okay, let's go this way. Look at here now. Let me open a diagram and show you. This is what all we have already discussed. Look at the diagram now. See here. Operator, access group is there, right? From access group, look at the top direction. Application, rule sets, rules. Correct, everyone clear? Operator, access group, we discussed portal, harness, section, controls. Operator, access group, access role, role to object, access when privilege, all this we did not discuss the third level. Okay, everyone clear? First 2 levels, these are the levels. An operator will have an access to a rule like this. Operator, access group, application, rule set, and rule. Versions you can leave about it, not a big deal. Rule authorization, whether you are authorized to access a rule or not, decided by which rule, which instance? An operator is allowed to access a rule or not, decided by which one? Out of all this in this diagram, which one is going to decide that? Access group. Access group is going to decide whether you have access to the rule or not. Look at here. Whenever a requester is requesting for a rule, process commander should understand this rule falls into same access group that this operator has in the rule set of the application of the access group that matching with this particular operator. I'll show you a diagram. Hold on. Open with Paint, and here you go now. When a requester is requesting for a rule, process commander is going to verify this rule is part of which rule set. This rule should be there in some rule set, right? It will, from the rule, it will find out the rule set in which this rule is available. It may be 1 or more rule sets. From the rule sets, it will find out these rule sets will be referred in an application, right? In which application this rule set has been referred. Application will be referred in what? Access group. Okay. So now process commander will verify the access group. Okay. Now, as part of this traversing, finally it has got one access group, correct? It has got one access group. There is an operator 1 requesting for a rule, and that operator 1 has access group. Some access group will be there for that operator. PRPC will collect the access group of that operator. Now PRPC has one access group in its hand. Now it starts rule authorization algorithm. From the rule that is requesting, it will verify what is the rule set in which the rule is available and what is the application in which this rule set is referred, what is the access group in which this application is referred. Now it has got one more access group, correct? The access group which it has got this as part of this traversing is matching with the operator's access group or not. Both are matching. That means operator has access to this rule. Both are not matching means operator doesn't have. See, look at here. The same is happening. I am an operator. I have my access group of LIC Auto I access group. I am requesting for a customer details section of SBI. This rule is part of rule set. Let's say SBI insurance. SBI insurance rule set is part of SBI application. SBI application is part of an access group, SBI access group. So now result is SBI access group. Operator who is requesting for this role, his access group is LIC authors. Is both the access groups are matching or not matching? Not matching. That means this operator doesn't have access to the rule. This is called rule authorization algorithm. Rule authorization algorithm is not top to bottom. It is bottom to top. Why it is bottom to top? Why not? See, I logged into an operator ID with an operator ID. It can verify my access group to all the application that I have, application to access rule sets to rules. The rule which I am trying to access is part of these rules or not, it can verify, correct? And if it is part of this one, to access, otherwise prevent access. Why Pega did not design it top to bottom approach? Why it has designed bottom to top approach? What was the reason?
Because of inheritance, and that tool might be coming
What
from
is
some
inheritance? It's nothing like inheritance. Why the algorithm is designed bottom to top approach? Why not top to bottom approach?
I mean, it has to verify all the other parameters in the rule resolution algorithm. Then it finally comes to authorization.
One place it is coming to authorization, right? When it comes to authorization, why bottom to top algorithm? Why not top to bottom algorithm? That's what I'm asking.
So the access group cannot be defined in the initial stage itself, right?
What is that? You already working on Pega, right?
Yes.
Yes.
The base is a rule set. On the top of rule set, we are developing application, right? In the application, we are setting the access group. On the top, we are setting further authorization.
See, you come from bottom to top, you come from top to bottom, you will at one point you will encounter everything, correct? Top to bottom, if you're coming, you will be getting bunch of rules. This rule is part of those rules or not, you will verify. Bottom to top you go, you have an access group, final one. That access group is not is matching with current operator or not, it has to verify. Both are same. I mean, anyway you go top to bottom or bottom to top, it will be resolved finally. Why Pega did not implement the algorithm top to bottom? Why it has implemented bottom to top? That is the question. Understand the question first. You ask anyone who is working on Pega since last 5 years or 6 years, why this has been implemented like this? I am not saying that I only know about it. There are many people who knows about it, but usually 99% of the people, they don't know. Okay. The reason being, yes, go ahead. Go ahead.
No, because actually here our journey is starting from at rule, right? So like even rule resolution is all about.
Your journey is starting in fact from operator. You logged in as an operator, right? And then you access a rule. You can even consider like that. It's not about where you start the journey. Why you start the journey at that place? That is the point. Why not you are starting from operator go into rule? Or you're starting from rule and coming back to access group? That is the question.
No, I'm talking about specific to the rule resolution when we are doing the rule resolution. So I mean the journey starts at the particular rule, right? So maybe that's the reason.
It started at the rule. So what? It started rule. So what?
As it started the rule. So part of I mean like rule resolution algorithm, we checked other parameters, other factors, and finally we arrived at authorization. Here also like we'll check from the rule and rule set. Likewise, like bottom to top.
Okay. It is not like that. No problem. You will be learning now. Look at here. See, you come from top to bottom first. When you come from top to bottom, an access group will have an application, correct? How many rule sets will be there in an application?
Yeah,
Imagine 4. 4 has again parent application. 4 into 4 plus 4. Again parent application. Possibility is there. You may arrive. Just say, let's say for example, Pega rules process commander rule sets itself 20 minimum. 20 plus 8, how many? 28. 28 rule sets, how many versions will be there? N number. I don't know. How many rules will be there in overall all these rule sets? Imagine 10,000. Out of 10,000, it has to perform a search of a rule. One rule. It's a time consuming process. Bottom to top you go. You started at rule level. Take a rule. This rule will be there in maximum of 25 rule sets. Okay, no problem. 28 rule sets. All rule sets, this rule is there. All these rule sets will be referred in how many applications? 4 applications. So search is now you are reducing the search. So previously 10,000 sets. Now 1 to 28, 28 to 4 applications. Let's say, imagine 4 applications will be access group. Let's say 4 access groups. So what? Out of these 4 access group, one of the access group will be matching with you, or none of them are matching. Search is being simplified. Yes or no? How many rules you are searching? Maximum of 30 to 40. But if you come from top to bottom, it can be 10,000 or it can be 25,000. I don't know. So you need to write your algorithms in a better way, optimum way. Okay, that is why Pega has developed this algorithm bottom to top, not to top to bottom. Top to bottom means it has to perform a search on all the rules tables, all the records. It has to perform a search, which is highly difficult. Understand? So that's why it is bottom to top, to simplify it for ease of search. So rule authorization. Rule authorization means whenever a request is requesting for a rule, process command is going to verify this rule belongs to which rule set, belongs to which application, access group. The access group that it has got is matching with the access group of the operator who is requesting. Both are matching. Allow access, else not allow. Understand? So this is about rule authorization algorithm. Finally, rule cache. You know about cache memory, temporary memory and matram japaka. Okay, shared memory. Cache memory means shared memory plus quick access. If I am going to place anything in the cache memory, it will be quickly accessible. Correct? The cache memory avoids the original source memory access. Correct or not? And cache memory avoids original source memory access. You don't need to go to every time original source place. Directly take it from the cache, done. Okay. So rules also will be there in cache tables. Whenever you access a rule, PRPC puts that rule in the cache table. That is called as rule cache. Okay. Now let's go to rule resolution algorithm. Rule will be picked from rule cache or maybe original place, whatever it can be. So in the rule resolution algorithm, we have rule cache, class inheritance, rule set hierarchy, rule availability, circumstance, and rule authorization. Class inheritance means always fixed from the current class, then not available pattern inheritance, otherwise direct inheritance till base class. Then rule set hierarchy means always from the current application, current rule set, and current application, all other rule sets, parent application rule sets, parent to parent, like that, Pega rules, process commander, Pega platform, OOTP rule sets. And rule set version always highest version. Rule availability, 5 availabilities are there. Available, not available. Sorry, available, final. Both will allow the processing. Final will prevent overriding. And not available, withdrawn. Not available means highest version only will be ignored. Previous versions will be taken from current class. And withdrawn means all versions of the current class will be ignored. It will take from the parent classes. Blocked means completely the rule will not be processed at all. And rule circumstance, always PRPC verifies whether the rule has circumstance. If circumstance is there, process command is going to verify the condition and date qualifier. If everything is matching circumstance version, else base version. And rule authorization, PRPC is going to verify whether the rule belongs to which rule set, application, and access group. That access group is matching with the current operator, whoever is requesting. Both access groups are matching, authorized, else not authorized. So considering all this, overall rule resolution algorithm has been designed. Look at here. So this, and including rule cache, I will tell you. So whenever a request is going to request for a rule, whenever a requester is going to request for a rule, process commander always verifies the rule cache. Process commander always verifies the rule cache. Rule may be there in the rule cache or may not be there, right? Rule may present. If it is there in the cache, what does it mean? It is already been accessed previously, correct? If it is not there in the cache, this is a rule cache table, not the memory in hard disk. Okay, so rule cache, if it is there means it is already been requested once it is been accessed. Cache, it is not there means this is the first time it has been requested, whatever it can be. The possibility is that rule may be there in the cache or may not be there in the cache. Let's say the first situation, when a request is requesting for a rule, rule is already present in the rule cache. Then PRPC picks the rule from rule cache and go to step 7. First step to 7th step, picking the rule from the cache. Understand? Then it will verify this rule is blocked or not. This rule is blocked or not. If not blocked, it will verify the operator is authorized to access the rule or not. If operator is authorized to access, then process the rule and present the rule to the request. Only 5 steps out of 10 steps are executed. If rule is present in the cache, PRPC picks the rule from the cache and verifies that the rule is not blocked, verifies that operator is authorized to access the rule, then process the rule and present the rule to the requester. Understand clear? Let's say rule is not present in the cache. If it is not present in the cache, PRPC will execute all the steps in the algorithm. First, it will collect all the rules with matching name and type, customer details section with same name, all the classes, all the rule set, all the versions, bunch of rules it will collect. These are the bunch of rules, out of which one should be processed and presented to the requester. Now it ignores the rules which are not available and not in the class inheritance hierarchy. The rules which are not in the class inheritance hierarchy, same name rule is there, but it is not there in the class inheritance hierarchy. Tell me the rules which will not fall into inheritance. What are the classes? What are the classes which will not come in the inheritance? A classes raw inheritance. What are the classes that doesn't fall into the inheritance?
Base class.
Data classes. What are those? Data classes, integration classes. These won't come in the inheritance part. Okay, so it ignores the rules from data classes, integration classes, like that, and ignores the rules which are not available. Any availability not available, those will be filtered out. So PRPC, when the rule is not available in the cache, process commander picks all the rules with matching name and type and ignores the rules which are not available, filters out the rules which are not available and also not in the class inheritance. Now there is some little bunch, and from that little bunch it is going to ignore the rules which are withdrawn and which are not in the applicable rule set hierarchy. Means other application rule sets, your application, parent application, okay, in same process command other applications also can be there, right? See here, when I search here customer details section, these two rules are not part of my current application rule sets, correct? Ignores the rules which are not in the applicable rule set hierarchy and ignores the rules which are withdrawn. So if a rule is not present in the rule cache, process commander collects all the rules with matching name and type and it ignores the rules which are not available and not in the class inheritance hierarchy, ignores the rules which are withdrawn and not in the applicable rule set hierarchy. Now you have some bunch of rules. Now from the final bunch of rules that it has, it ranks the rule by class inheritance, rule set hierarchy and circumstance. All this will be. So let's say it has a final bunch where framework work class, implementation work class, organization class, OODB classes. Ranking will start. Imagine highest rank is the current class. Okay, and now highest rank rule will be picked. Current class. Out of all this bunch, current class will be picked. This has again circumstance. Then what it is going to do? It will verify the circumstance is there or not there and condition is matching or not matching. Let's say condition is matching. Then which one is best instance? Circumstance instance is best instance. If condition is not matching, then base version is best instance. Understand? So it picks the rule accordingly by considering the circumstance factor as well. And now finally it has only one rule in hand. That will not be processed directly. That will be put into cache. That will be kept into cache. Okay. Now it picks from the cache, verifies that the rule is not blocked, verifies that operator is authorized to access the rule, process the rule and present the rule to the requester. This is what rule resolution algorithm. So rule resolution algorithm starts getting executed whenever a rule is being requested by a requester. process command starts executing rule resolution algorithm, verifies that the rule is there in the cache or not. If rule is there in the cache, picks the rule from the cache and process and verifies that it is not blocked, and verifies the operator is authorized to access the rule, process the rule and present the rule to the requester. If rule is not present in the cache, PRPC picks all the rules with matching name and type and starts filtering the rules, ignores the rules which are withdrawn, not in the applicable, ignores the rules which are not available and not in the class inheritance hierarchy, and ignores the rules which are withdrawn and not in the applicable rule set hierarchy, and it ranks the rule by class inheritance, rule set, versioning and circumstance. It will verify if the rule has circumstance or not from the current class, current application, current first rule set. If circumstance is there and everything is matching, circumstance is the best instance, else base version is the best instance. Then once it gets the best instance, it will put back that instance into cache and picks from the cache, verifies that the rule is not blocked and operator is authorized to access the rule, then process the rule and present the rule to the requester. This is all going to happen in the rule resolution algorithm for each and every rule that is being requested by a requester. Understand everyone? Clear? Every one of you online? Clear?
Yes, sir.
Okay. So if you are going to block a version 4, can you create version 5 with unblocking? Possible. You can create. You can create version 5 as available. See, now I have one question in this rule resolution algorithm. Do you have any question here? Withdraw ki blocked ki difference ఏంటి? Difference ఏంటి? With blocked you can easily remember. Blocked అంటే ఏంటి? Completely stop it. Don't process at all. Withdraw means only current class, all versions will be ignored, parent class it will take. Not available means current class, current highest version not available, only that will be ignored, previous version it will pick. చెప్పండి ఇప్పుడు బానే ఉంటుంది, వెళ్ళి మీరు చూసాక ఏమర్థం కాదు. చెప్పండి, what is the doubt? Any doubt, any question here?
Harsha, I have one question. After 7th step, why it only verifies for block status? Why not?
That is what my question also. Why Pega is verifying the blocked at 5th, 8th step? Why not at the beginning itself? Why? What was the reason it is verifying at the 8th step? Why not at the beginning? Beginning itself it, so imagine beginning itself it is verifying for the blocked. Blocked is there, it is going to stop the processing. So beginning, if it is going to verify the block and stop, is that the correct approach or not? We need to understand that. Imagine it has collected all the rules with matching name and type, and imagine you have blocked a version. Let's say version, I have 4 versions in the current rule set. Version 3 is blocked. Version 3 is blocked, but not version 4. Version 4 is not available. What is version 4? At the very beginning itself, if it is going to look at the highest version always, right? It is going to verify the blocked. Highest version is blocked or not? Version 3 is blocked, correct? Beginning itself, if it is verifying block, where you need to keep it? Version 3 is blocked, not version 4. Version 4 is not available, which means that blocked should come after not available. Not available, you filter, then you encounter block, then you stop it. Suppose beginning itself, if you remove block, version 3 is blocked, version 4 is not available, version 2 is available, it will pick version 2. Is that correct? Picking version, see, version 2 is available, version 3 is blocked, version 4 is not available. When I execute this, what should happen to the rule? Rule should be picked or not picked? Rule should not be picked. Not available means it will go to next previous version, next highest version. I mean like previous highest version. Previous highest version is blocked, means it should stop, right? At the first step before not available itself, if you filter out blocked, if you look at blocked, highest version is not blocked, version 3 is blocked. Version 3 is blocked means version 2 should not be picked, but version 4 is not available. After you filter out version 4, then only version 2 will be looked at, correct? The situation may be there, can be there, correct? So at the very beginning itself, if you are going to look for blocked and if you are going to stop, even the next version is available, it will stop. That is not correct. So blocked doesn't fit at the first level, it will fit only after not available. Okay, after not available it is fitting. After not available, again you are verifying withdrawn. You block parent class and current class you make it withdrawn, what will happen? Rule will not be processed at all. Before withdrawn itself, if you try to verify the blocked will not be encountered. Highest version is withdrawn, correct? So blocked being before withdrawn also not a possible situation. It has to be after verifying not available, after verifying withdrawn only blocked should come. Okay, blocked is now coming at the 5th step. At the 5th step, if you are going to get the blocked, circumstance instance is available, base instance is blocked. Okay, circumstance instance version 4, base instance version 3. Circumstance condition is not met. Condition is not met. Then it has to go for base. Yes. Otherwise, same version also you can take. See, if you are going to make blocked is being considered at the beginning, any place. After blocked, as someone was asking, you may have further availability available, or withdrawn, or maybe circumstance rules and all, right? Possibility is there. After filtering those things, then only you have to finally consider blocked. Blocked being highest version is okay, but blocked is internal version and highest versions are not available, then that is the issue. So blocked doesn't fit before not available, before withdrawn, even it doesn't fit before circumstance also. Then where it should fit only after all this. After all this, it will verify only properly, it will be prevented. Otherwise, it will not be prevented at all. That's why blocked is being maintained after picking the right instance from the cache. See, 4 is not available, 4 is filtered out. Okay, and version 2 is withdrawn. It will go to parent class. Parent class, when it go, parent class highest version is blocked. Now, considering if you are going to stop here itself, that is not correct. First, you take that blocked as a best instance, no problem, and put that blocked as in the cache. Pick from the cache, you verify. Then blocked you are going to prevent or not. So blocked being here at that 8th step after picking the best instance means blocked also should come into processing. After it gets into the processing queue, then you prevent it. That's the point. You should not prevent it before itself. That will create problems. You make it available for processing. It is entered into processing queue. Now you identify. Processing queue means cache. That is the best instance. Okay. Highest version is blocked. Best instance. Okay. Put it in the cache. Pick from the cache. Now you verify. It is blocked. You stop it. So that is how the algorithm has to be. So before not available, it doesn't fit. Before withdrawn, it doesn't fit. Before circumstance also, it doesn't fit. Okay, it will fit after all this. After all this means where? After you pick that instance, right? If you want to pick that instance, you have to put back into cache and then pick. That is the algorithm. You pick it and then verify the block. That's why blocked is at the 8th step, not at the beginning. Okay. Any other doubts or questions? So if anyone is going to question you about the rule relation algorithm, you have to explain everything clearly in detail. After you explain this rule relation algorithm, he will ask you what is rule authorization. You are just telling the rule authorization as one step in the rule relation. If you have to explain rule authorization again, you have to explain each of these steps. You have to detail. You can in detail explain or not. Class inheritance, rule set hierarchy, circumstance, rule authorization, rule availability. All these are small algorithms, sub algorithms together one final algorithm called rule relation algorithm all together in an order. Okay. So that's it for now. I'll be sharing the document related to rule relation algorithm. Watch this video 2 or 3 times. Okay. I'm going to close the meeting. Thank you for joining.